If you're ready to do math today and you have your coffee ready, join me in the simultaneous sip. The question we're working on today is, let B be the set 1 plus t squared, t plus t squared, 1 plus 2t plus t squared, and let P be the polynomial 1 plus 4t plus 7t squared. First, show that B is a basis for P2. And second, find the coordinate vector of P relative to B. To show that B is a basis for P2, what we're going to do is we're going to take our polynomials and express them as vectors in R3 and show that these vectors are a basis for R3. And that will show that B is a basis for P2 because P2 and R3 are isomorphic. They're basically the same vector space. So to get our corresponding vectors in R3, we just read off the coefficients of the polynomials. And now that we have our three vectors, we could put it in a matrix, and we're going to row reduce this matrix and look for the pivot columns. And we'll see that we'll have pivots down the diagonal. And by the invertible matrix theorem, that means we have linearly independent vectors that span R3. Hence, we have a basis. Now would be a good time to pause the video and comment below what your favorite part of bases are. Mine is showing that they're linearly independent and span the whole space. And while you're down there, make sure you smash that like button and subscribe. All right, back to the show. Now to find the B coordinate vector for P, we're going to do the same thing. We'll express P as a vector in R3. And now we'll set up an augmented matrix and row reduce the crap out of it until we could figure out what our solution vector is. So we have to row reduce until we're in reduced row echelon form. And now we can conclude that our polynomial is 2 times P1 plus 6 times P2 minus P3. So our B coordinate vector is 2, 6, -1. Make sure to subscribe for more Coffee and Math with Dr. Weselcouch. Don't text and drive. Bye-bye.